Okay, and I hope you brought your graphing calculator today because we're going to learn how to do sequences on the calculator. 1 BTG. Okay, did everybody get caught? Did you even pick up the worksheets? Boy, it's just snowballing. Walk, Terry. Boy, I gotta walk to you also. Next. Is anybody else gonna be missing school? When you miss school, it's not a jolly holiday, I'm telling you guys. When? Next week, Friday. Isn't that family fair? So we don't have class if you're an 11th or 12th grader.
Thursday.
Why, what's Thursday? Did I already sign the paper? If you're gonna miss school, is it an excursion?
Yeah.
It's an excursion for what class?
Just don't go.
Being pulled out of class for chemistry?
Just don't go.
What's going on? What next?
Just don't go.
Okay, number 1B. 8, 4, 2, 1, 1/2, ... It says find the explicit formula for the following sequence. Now, first you ask yourself, is it arithmetic? Does it have a common difference? No.
No.
Is it geometric? Does it have a common ratio? Yes, so if it's geometric or arithmetic, you have a formula. So for geometric, what was the formula again? Yeah, that's the formula. So in this case, A1 is the first term, which is 8. What is the common ratio? What number do I keep multiplying by? 1/2 to the n minus 1. There it is. Yeah, but that's not the answer you have on the bottom. That's because I simplified it. Hello. And that's, did you guys at least write that on your paper? To get 5 out of 6 points? Well, you don't have anything this simple. Well, do you notice that these are all powers of 2? Isn't this the same thing? Isn't 8 the same thing as 2 to the 3rd power? And then 1 to any power is 1, and then 2 to the n minus 1, like that. And then what do you do with the exponents when you have a common base and you divide? Add, subtract, or multiply? You subtract. So what is 3 minus that? 4 minus n. It's called simplifying. So the whole problem was you didn't know how to simplify. Apparently, again, same reaction. D. You guys better pick it up for tomorrow. D. 8, 12, 18, 27, 40.5, ... Is this arithmetic? Keep adding 4 every time. Don't be ridiculous. What about the common ratio? Do I keep multiplying by the same number? Yeah, what is that number? 3/2. So again, just use the same formula. First term times 3/2 to the n minus 1. You know what? I'd be happy with that. Forget simplifying. Just write that and give you credit. Anyway, that's what I wrote right there. People, if it's arithmetic or geometric, you gotta pounce on it like a wounded wildebeest. It's like you're the wounded wildebeest. G, 1/2, -2/5. That's not -2/5. -2/5, 3/8, -4/11, and ... I'm not gonna write all of it. Okay, now when you look, especially when you work with fractions, sometimes it's easier to look at the numerator and denominator separately instead of like the fraction as a whole number. You know what I'm talking about? So the first thing you notice is, hey, the thing is going positive, negative, positive, negative. We learned how to do that yesterday, right? What makes a sequence alternate positive, negative, positive, negative? -1 to the n or n plus 1? N plus 1, because if you plug in 1, you want it to come out positive. Okay, now look at the numerator. Okay, so we're gonna look at the numerator and denominator separately. Numerator, 1, 2, 3, 4. Is there a pattern to that, or these are just random numbers? It's just n. It's just an arithmetic sequence with common difference 1. Now what about the denominator? 2, 5, 8, 11. hey, it's arithmetic. The common difference is 3, so 3n, and then you adjust. If you plug in 1, you want to get 2. So minus 1. And then, katana! Woo! Ouch. Next, 5, 6, 7. Congratulations. Number 5 is just like number 4, except it's different. It's just worded differently. So let me ask you this. How did you do number 4 then? So tomorrow I guess I'm going to have to call on people like Leon, how did you do number 4?
Right, 53.
Then why isn't it on the board, Leon? What about Chen? How did you do number 4?
I wrote out like A1 plus D.
A1 plus n minus 1d. And then just plug in the numbers. Exactly, that's all you gotta do. So look, no, okay, why don't we do number 4? Oh, gosh. People in this class, if you can just how many terms are in the sequence? I don't know. Should I just write them all out and count? I don't think so. What kind of sequence is this? It has a common difference because I told you it says arithmetic over here, right? So just use this formula. A1 plus n minus 1d. Okay, now you start plugging in. What do I plug in for a sub n? 336. That's the nth term, except I don't know what n is. You know what I'm talking about? So this is 336. What do I plug in for a1? 18. What do I plug in for d? What's the common difference? 6. What's the only variable left to solve for? N. So you solve for n, and what does that tell you? That will tell you what term that is. That's the nth term. So if you solve this equation, that tells you exactly what term that is. That's the answer. Oh boy. You don't remember doing that last year in algebra? I know nothing. I remember nothing. I'll give you nothing. Okay, so now that I taught you number 4, we can do number 5. Anyway, I believe number 5 will be, in fact, on number 7, it will definitely be on Friday's quiz. Probability 1. I hope we know what that means now. How many 4-digit whole numbers are not divisible by 11? Now you gotta ask yourself, is it easier to count that or to count the ones that are divisible by 11 and subtract it from the total? Yeah, do the complement. So why don't we count how many 4-digit whole numbers are divisible by 11? Now what's the smallest 4-digit whole number that's divisible by 11? 1001. How do you know that? How can you tell if a number is divisible by 11? Just try to divide it into it and see if the remainder is 0. Or is there like something we learned in elementary school? Yeah, you look at every other digit. Okay, let's go back to elementary school. I'll just make up a number. 5, 3, 4, 7, 2, 1. How do I know this number is divisible by 11? You add, okay, starting from the first digit, you add up every other one. What's 5 plus 4 plus 2? Then starting from the second one, you add up every other digit. What's 3 plus 7 plus 1? If you subtract those two, if this number here is divisible by 11, then the whole number is divisible by 11. Is 0 divisible by 11? Yes. Hi, we. That means yes. Okay, so like here, what's 1 plus 0?
1.
What's 0 plus 1?
1.
What's 1 plus 1 minus 1?
0.
Is 0 divided by 11?
Yes.
Yes, so this number is divisible by 11. You just count every other digit. This is prenatal. This is not even preschool. It's prenatal. Whatever that means. Okay, what would be, okay, now if we're looking at all the multiples of 11, what would this next number be? 1,000, I'll give you a hint, just add 11 to it.
12.
12. What's the next one going to be? 223. And then finally, going all the way up to what's the largest 4-digit number that's divisible by 11? This one you better get. 9999, right? Because look, 18 minus 18 is 0. Plus, you know 11 goes into 99, I would hope. Mr. Park, this is just like this problem now. You bet your sweet pippy it is. So you just use that formula. What do I plug in for AN? 9999. Okay, goodness for you responding. A1, what do I plug in? 1001. Yeah, tomorrow I'm gonna be waiting for a response. Plus n minus 1. What do I plug in for D? 1%, thank you. And then all you gotta do is solve for n, and that tells you how many terms there are in this sequence. But then we gotta find out how many are not divisible by 11, so we have to subtract that from the total. So we have to know how many total 4-digit numbers are there. Let's use combinatorics. Here's a 4-digit number, it's a permutation. How many choices do I have for the first digit? 9, because 0 cannot be the first digit. How many choices do I have for the second digit? 10, 10, 10, 9,000. So what you do is you solve for n, subtract that from 9,000, and that's your answer. Can do, huh? Number 6. The logarithms of a geometric sequence form what kind of sequence? Wait, let me look at the bottom. Okay, how do you write a geometric sequence? If we call the first term A, how do I label the second term? We did this yesterday. If this is geometric. AR. Geometric sequence, you keep multiplying by the same number, and usually we call it R for the ratio, right? What's the third term? Multiply by another R. Multiply by another R. And you keep on going. That's how you label a geometric sequence. Now the question is saying, if I take the logarithms of these terms, what kind of sequence do you have? So let's do it. Natural log the first one, natural log the second, natural log the third, natural log the fourth, and so forth, etc., etc. Mr. Park, I don't see it. Well, that's why you need to use your property. That's why I put this problem on, so that you would review your properties of logarithms. Say what? Let's dig deep, people. What is natural log of something times something? What do I do?
Natural log is something plus the
Natural log A. Oh, very good. Period 3. Things are looking up. The sun will come out tomorrow. Oh, but Mr. Park, natural log R squared. There's something I can do with the power. Put it in. Oh, you guys are on it today. What's happening? Wasn't expecting that. And then the last one, natural log of A plus natural log of R cubed, but I can put the power in the front. Now that you look at it, hey, what kind of sequence is that? Arithmetic. And what's the number that I keep adding every time? Natural log R. Isn't that a neat problem? I don't know why I asked that. And then number 7. Okay, here we go. This is the one that separates the goats from the sheep. How many people got it without guessing and checking? 2 people.
I have a question.
Yeah.
I still don't understand what sheep, separating the sheep and goats. Aren't they both useful?
Yeah, for meat.
And like milk?
And for fur.
Yeah, so like, I don't get how they're different in quality.
Because, like, okay, in sports, let's say it's a tie game, bottom of the last inning, no, no, it's not a tie game. You're up by 1 run, and you're on the field. You're the visiting team, and a pop fly, easy pop fly to the second baseman. He comes under it. He drops the ball. What do we call it? What do we call it? You're a goat. You never heard that? A goat means like you flubbed it. That's what a goat means.
Really?
Yeah.
I think we just use different terminology.
But what do you say nowadays? You can't repeat it in class. A goat means you blew it. So would you rather be a sheep or a goat?
Sheep.
Okay.
Also, sheep are good and goats are bad.
No, I don't know. Sheep. Well.
Yeah.
Okay, let's just do this problem because the probability is 1 that it's going to be on Friday's quiz. given a 4-term sequence like this, so write out the 4 terms. The first 3 terms form a geometric sequence. The last 3 terms form an arithmetic sequence. If the first term is 2 and the 4th term is 30, what are the second and third terms? Now, some people can actually like figure it out, guess and check, but you only get one answer. You gotta get both answers, people. There's 2 answers, that's why. And I only made it come out nice because the first answer you can guess and check with whole numbers. What if I made both of them come out to fractions? Then there's no way you're gonna guess it. You gotta be able to write an equation so that you can solve it. Anyway, on Friday's quiz, every year, there's always 3 or 4 people, they just guess and check one of the answers, because I'm nice and people. Then in that case, you're gonna get 1 out of 5 points. I need to see both answers, I wanna see equations. Okay, now the first 3 terms form what kind of sequence? Geometric. So this is geometric, the first 3 here. So if the first term is 2, how do I label the second one? Just like over there. 2r. You multiply by the common ratio. How do I label the third one? 2r squared. Geometric means you multiply by r, then you multiply by r again, right? See, if you don't label it correctly, you don't get into the problem. Okay, now what if I said, because sometimes I change it around on the quiz, what if I said the first 3 terms form an arithmetic sequence? How would you label it? 2 plus d, then you add another d. 2 plus 2d. You get it? That's how it all begins, people. Okay, and then it says, the last 3 terms form an arithmetic sequence. So, if these 3 terms form an arithmetic sequence, what equation can I write? Okay, I'll tell you, this minus this equals that minus that. 2r squared minus 2r equals 30 minus 2r squared. How come? Okay, let's go back to yesterday. What's an arithmetic sequence? It has a common difference, right? Like 2, 5, 8, 11, 14. Everybody agree this is arithmetic? Why is this minus this equal to that minus that, which is equal to that minus that, and that minus that, and that minus that forever? Because that's how you obtain the common difference, right? This minus this is 3. That's the common difference. You get it? So since this is arithmetic, this minus this gotta equal that minus that. What if it was geometric? Then this divided by that gotta equal that divided by that. You know what I'm talking about? Okay, now we've got an algebra 1 equation. Everybody here can solve this. Can you guys take it from there?
Yeah.
Take it and run with the ball, or you're gonna fumble. Make one side 0, it's factorable, people, and then there's 2 answers for r. That's why there's 2 answers on the bottom. Yeah, I think you can take it from there. Okay, today we got there's only actually 3 lectures for this chapter. Today we got recursion, and tomorrow we got limits of sequences. And then after that, we're just gonna practice for a while.
Are you doing anything special for extended?
Didn't I say we're gonna video?
Oh yeah.
Yeah, we're gonna video. We're gonna recreate that class somehow.
So no movie or anything?
No, well, we would have watched Flatland, but okay, here we go. Now, yesterday we learned how to write explicit formula for sequences, right? Like if you want the 10th term, you just plug in 10. You want the 100th term, you plug in 100. But now we're going to look at a different kind of sequence. It's going to be defined recursively, like this. Here's an example. A sub 1 equals 2. A sub n is equal to a sub n minus 1 plus 3. This is a sequence defined recursively. Okay, now on tonight's homework, I believe the first problem is write out the first 5 terms of the sequence. Okay, what's the first term? 2. How do you know that? Because it says so right here. A1 is the first term. The first term is 2. Okay, how do you get the second term? Well, you have to be able to understand what this is. This is called the recursion formula. Okay, if a sub n represents any term in the sequence, okay? What do you think a sub n minus 1 represents then? Yeah, the one before it, exactly. right? Because isn't n minus 1 1 smaller than this? So if this represents any term, this represents the term before it. So to get any term in the sequence, you take the previous term and add 3. This is a simple recursion formula. So if I want to find the second term, you look at the previous term and add 3. 5. To get the third term, you look at the previous term and add 3. To get the fourth term, you look at the previous term and add 3. 14. There you go. I wrote out the first 5 terms. That's what you got to do on number 1 of tonight's homework. But they're not going to be quite this simple. Okay, now what if I were to ask you, find the 100th term? Oh, easy, Mr. Park. Just keep doing it then. To get the next term, look at the previous term and add 3. Add 3. Add 3. Am I there yet? What if I ask for the 1000th term? Well, since this is 2013, I like to ask for the 2013 term. What do? You don't keep doing this. This is crazy. I mean, yeah, you can. What do? You use the explicit formula. Because what kind of sequence is this? It's arithmetic. We learned it in history. So what would be the explicit formula for this sequence? The common difference is 3. 3n, adjust! Minus 1. So if you want the 100th term, just plug in 100, you get 299. See, so recursive formulas are good in certain types of situations, and explicit formulas are good in other types of situations. You gotta know which one to use. You guys know what I'm talking about? Okay, what about this? A1 equal 3. an equal an minus 1. Oh, an equal 2an minus 1. Write out the first 5 terms. What's the first term? 3. It says so right there. Now what does this mean? To get any term in the sequence, you take the previous term and add 2. Multiply by 2. Right there, multiply. I don't see the problem. Watch the video. I didn't say add. So if you want the second term, take this term and times it by 2. If I want the third term, you take the second term and times it by 2. Times by 2. Times by 2. There you go. That's the first 5 terms. What's the 100th term? Just keep writing. No, write the explicit formula. What kind of sequence is this? It's geometric because you keep multiplying by the same number. So what's the formula for geometric? This is last night's homework, people. First term times r to the n minus 1. So therefore the 100th term would be 3 times 2 to the 99th power, which is a really big number. Okay, are you catching on to recursive? Okay. So now we can kick it up a notch. Of course, the most famous recursive formula in the history of mathematics is this one, right? A1 equal 1. A2 equal 1. an is equal to an minus 1 plus an minus 2. Okay, let's write out the first 10 terms. Write out the first 10 terms. What are the first 2? 1 and 1. How do you know? Because it says the first term is 1, the second term is 1. To get any term in the sequence, you take the previous term and add the 1 before that. So if you want this, you gotta add the 2 terms that come previously. 2. If I want this term, you gotta add the 2 terms that come before it. If you want this, you gotta add those 2. You want stop saying that. Is that 10 yet?
No.
What do you mean no? Yes. That's 10. That's the first 10. And of course, you guys recognize this as the Fibonacci sequence. When did you guys first learn that? Elementary school? Prenatal? Preschool? Most of us learned it in the womb, but whatever. Okay, what is the 1000th term? Just keep writing. No, you write the explicit formula if you're gonna find a large number. So what is the explicit formula for the Fibonacci sequence? Now math team people, you should just know this, right? Try. Put it on the worksheets and everything. This is like the dagger right here. Quack. No, this is just a... Okay, I'll tell you. It's 1 over root 5. 1 plus root 5 over 2 to the n minus 1 over root 5, 1 minus root 5 over 2 to the n. So if you want the 1,000th term, just plug in 1,000. What? That's common now. And look, hey, you somebody. That's the golden ratio again. Now what does the golden ratio have to do with the Fibonacci sequence? I think I showed you before, but nobody remembers. What if we form a new sequence? Just like, remember I told you when did I first show you the Fibonacci? Remember I told you like 4-leaf clovers, people think they're lucky? That's because they're rare. That's because most clovers have 3 or 5 petals. They don't have 4. Remember, Fibonacci numbers come up a lot in nature, yeah? What the heck is going on?
Don't care, Daddy. Thanks.
Yeah. Well, then copy it down. I didn't put that in the notes?
It's an example.
Ooh. It's in the examples. Try. Strike 1! Cito knows. Oh, the math thing, this is common knowledge. You don't need notes for this. Anyway, what does the golden ratio have to do with this? Well, why don't we form a new sequence? Watch this. I'm going to take each term of the Fibonacci sequence and divide it by the previous one. 1 divided by 1. 2 divided by 1.
2.
3 divided by 2. 1.5. Let's change it to decimals. 5 divided by 3. 1 2/3. 8 divided by 5. 1.6. 13 divided by 8. 1.625. And so forth. I don't think you can do 20. You guys can't even do 21 over 13 without a calculator, yeah? Anyway, hey, look at these numbers. These numbers are look like they're getting closer and closer to something. That's right, the golden ratio. Because remember the golden ratio, what do we call that? Phi is approximately 1.618, yeah? Look, these numbers are getting closer and closer to it. So that's what the Fibonacci sequence has to do with the golden ratio. Okay, enough with the golden ratio and the Fibonacci sequence. Anyway, in nature, remember a lot of things come. Remember that thing with the banana? Did anybody do the thing with the banana that I told you guys to? You guys know what a banana is? Okay, banana is this yellow fruit. You get the banana, you press the thing in, and the thing divides into 3 parts. Remember I told you guys? Nobody tried that? That's a Fibonacci number.
What do you do again?
Okay, you peel the banana, and then you look at the banana like that. You just take your finger and you push it in like that, and the thing just splits into 3 parts, naturally. Every single time. Mr. Masanaka taught me that. We did this at a department meeting. He brought it like that. He brought in this box of bananas. Everybody had one, and we peeled it, and we put our fingers and press it in, and everybody's one split into 3 parts. Did you guys do it in his class? Okay, whatever.
Do you eat it after?
If you want to,
No, like,
you got 3 then instead of this 1. So it's more. Okay, now how do you do? Okay, anyway, so since these numbers, this is actually tomorrow's lessons, these numbers get closer and closer to the golden ratio. We say that the limit of this sequence is the golden ratio. That means as n gets bigger, as you keep on writing out more terms and more terms, they get closer and closer to that number. So we say the limit of that sequence is that number. Now some sequences, it's very easy to find the limit, but some are very difficult. We'll talk about that tomorrow. Today we're going to learn how to do sequences on your calculator. Okay, so here, let's say, I'll give you a problem that I think is on your homework. Let's say you have a baby. Okay? Now, when you have a baby, you gotta think, oh, probably 18 years from now, he or she's gonna go to college, so we wanna start a college fund, yeah? So let's say we put initially $10,000 into an account. Okay, now I put it into the account. How much percent does this account get per year? What kind of interest does it get? Just make up something. 5%. Why is that what it says on tonight's homework? Okay, so to get any term in the sequence, you take the previous term. So if it earns 5% interest, then what? What do I multiply the previous one by? 1.05, right? Itself plus 5%. Just like, okay, when you go to the store, okay, let's say you have something, you buy something, costs $38.95. How do you figure out how much, with tax, how much you pay? Don't you just multiply by 1.04625 or whatever it is? Same thing. Multiply by 1.05, right? Good, then it's 5% higher. But then on top of that, every year, besides the interest it earns, I'm going to put in another $2,000 also. So do you see how this recursion formula works? You start with $10,000. At the end of 1 year, you multiply it by 1.05, that's the interest it earned, plus I'm going to put in another $2,000. And I'm going to keep on doing this until my child turns 18, and then that's how much is going to be in the account for their college. Okay, so my question is, okay, at the end, on his or her 18th birthday, how much money is in that account? Well, isn't this just a recursive formula? Okay, now how do you do recursive formulas on a calculator? Take out your calculator. You have 5 minutes to learn it.
We're running 2,000 every year.
Yeah, every year. So not only do you get the 5% that you earn, you're putting in $2,000 on their birthday.
So we have more.
No, so you multiply the previous amount by 1.05, so the 5% earnings, and then you add $2,000. Yeah? Okay, now TI people, press the mode button. What are the 4 modes? Pole, pars, func, seq. This is a sequence, people, going to sequence mode. Now on the prism, you go to the menu. What do you call it? Or that screen that has all the different thingies on it? The menu, and go to recursion. I think recursion is on the second row, but it's to the right. Am I correct? Go into recursion. Okay. Now TI people, press the Y equal button. What do you see? No, the Y equal button? No. Oh yeah. N min equal 1. Of course, you want to start with the first term. Okay, what's the second thing it says? U of n and U of n min. U of n min. Okay, this is where you type in the recursion formula. So you punch in 1.05 times the previous term plus 2,000. Now, when you on the TI, there's 3 sequences you can do: U, V, and W. U is a no. Mr. Park, where do I get the U? Well, sure. Look on your look at the buttons. Look above the buttons. Where do you see U? Not capital U, though. U, sequence U, above the 7. Above the 7, that's where you get the U. And then, Mr. Park, how do I get the N? You press the independent variable button. X, T, theta, N. If you're in sequence mode, the N comes out. Remember, if you're in func mode, the X comes out, parametric mode, T comes out, polar mode, theta comes out. So since we're in sequence mode, the N comes out. And then U of N min, well, if U of N min is 1, then what's U of 1? That means the first term. I'll tell you here, point at it, $10,000. Because if you don't state what the first term is, how does your calculator know what to multiply the first term by? You gotta tell the calculator what the first term is. Okay, now prism people. Recursion. Yours says A of n plus 1 equals, and then you punch in the recursion formula. 1.05. Now, is it throwing you off that they have A of n plus 1? It doesn't matter. Then you put A and n here plus 2,000. Because if this represents any term, then that's just gonna be the one before it, right? Because it's one less. So that's what you're gonna type in if you're in Prism. Okay, and then execute. Okay, now, when you look at a sequence, to me, the best thing to do is look at it in a table. So you can see all the values. Because your calculator can graph it, but I think it's more useful if you look at it in a table. So for those of you with the TI, before you press that table button, you gotta set the table. So table set.
Oh.
We've been doing this for how long? Okay, table set. What does it say? Table set. Table set. Table start. Where do we want to start the table? Table start. What? 1. We want to start with the first term. Delta table. What increments do you want to go in? 1. Right? Then the next, you just keep adding 1. First term, second term. And then you press the table. Okay, now the Prism people. Look at all your options. Press table. Here you go. Scroll down. Mr. Park, the thing stops at 5. That's because that's the default. For the, I don't know why that's kind of crazy. For the Prism, it only goes from 1 to 5. So how can I change that? Because 5 is just not enough. What do I do?
So back to the main screen.
Oh yes. Oh yeah, n. So you got a table setting. So instead of the n being 5, you should make the n like 100 or something. Okay, now, I would suggest this to you. We only got 1 minute left. When you're looking at the table, okay, what does it look like? Okay, TI people, what does the table look like? N, U of n?
Yeah.
Okay. Okay, so the first term is something, or it's 10,000, right? Second term, what term do I need to? So what term represents the 18th birthday? Is it the 18th term? No, because the first term is when the person is born. There's 0 when they're born. The second term is on the first birthday. So on the 18th birthday, what term do we need? We need the 19th term. This is the number you need. Put the cursor here. You know when you scroll down your table, put the cursor over here. It looks, and then you can see all the decimal places and things like that too. And same thing on the Prism. Move the cursor to the right-hand column. That way you can, the calculator shows all the decimal places. So, how much is money? Okay, the bell's gonna ring quick. How much money is in the account on the 18th birthday? How do I look up?
$80,330.96168.
$80,330
.96.
and 96 cents. Congratulations, you can almost pay for 2 years of college with that. So that means you gotta increase that amount, and you need a better percentage on your interest rate, and you can make more money. But it's hard to get, how do you find an investment that gives you a better return? Hard to find that. People wanna know that. Okay, so tonight I believe you're gonna be using your calculator on 3 or 4 different problems, yeah? Okay, tomorrow, you need to be receptive and reactive. Yeah, no need. It'd be funnier that way.